Hello, and this is Gilbrian Haramilia. This is activity 1. So, application. So, what is 3D graphics? Basically, it is a space that has an X, Y, and Z for height, width, and depth. It can be viewed and, for example, an object in all angles like top, bottom, left, right, and it can also be scaled from large to small or small to large. You can also rotate it like translation, and then rotation, and then scaling. Or scale or larger to small. So examples of application of 3D games, as you can see, we have here games. One in movies like CGI. Here on the middle, on the fifth picture, is animation that uses 3D graphics as well. The sixth photo is a game called Fallout. They use also 3D graphics. We can also apply 3D graphics in VR and AR as well, augmented reality and virtual reality, and many more. So, role of mathematics in graphics. Mathematics is fundamental to rendering realistic graphics in video games. Concepts like geometry, trigonometry, and linear algebra are applied to create 3D models, define camera perspectives, and calculate lighting and shading effects. How is mathematics used in graphics? The most important topics for starting out in graphics are linear algebra and trigonometry. We shall describe the location of a 3D graphics object according to its x, y, and z coordinates. We can then apply the following operations on a 3D object: translate, move, scale, change size, and rotate. So here we can also use multivariable calculus. So multivariable calculus is the differentiation and the division of functions involving multiple variables rather than just one. Basically, a single variable calculus is only a 2D space or x and y. So you can only see the front of it. So it only has x and y, height and length or width. And while in multivariable values, it's a 3D space that has a depth. So it has like a mesh. It's like 3D real life. So it has depth to it rather than just a shape that only has left and right. Differential geometry, measurement of properties of curves and surfaces of a 3D model or in 3D graphics as a whole. So like planes and stuff. Computational geometry. It is used in collision detection, for example, a ball from a billiard. Yes, when you hit the ball, hit the white cue ball to hit the object balls to the direction you want the object ball to go. The trajectory of it is related to the computational geometry. Computational geometry is also used on other things such as classification of polygons, triangulations, convex polyhedra, bounding volume problem, and convex hull. Numerical linear algebra. This is for positioning and movements, character or an object in a game or in an animation of sorts. So when you're walking, running, or when you want to put something in the world, you will use numerical linear algebra. Optimization. This is for like if it's compatible, your game is compatible for Android, iOS, or Mac and Windows, or console as well. Optimization can also be in changing the graphics, like high, low, and medium, like anti-aliasing, sons of partial differential equation. This is for water physics, for the process of its physics. It solves multidimensional dynamic system. It is also used for transverse vibration of an elastic membrane, heat equation for heat flow. It is for scientifically understanding heat, sound, diffusion, electrostatics, electrodynamics, thermodynamics, fluid dynamics, elasticity, general relativity, and quantum mechanics if you want to use them in your game. Ordinary differential equation is for animation characters or other entity in a game. Also used to describe the movement of electricity, motion, pendulum, and waves. This is simulate movement of objects, including their velocity, acceleration, and collision detection. This is like for physics and stuff. Signal processing. This is for changing and for image synthesizing. For example, a 2D image, we can change its contrast, and we can also do things such as blurring, warping, and sharpening the image. This is for shape of a surface or a motion of an animated character as well. Monte Carlo integration methods. This is to predict certain outcomes on a certain game through a simulation. This is like for physics and stuff, so you will use this simulation in order to calculate the physics, predict what its outcome will be, so on and so forth. To analyze the past data and predict a range of future outcomes based on a choice of action. So in graphics, it uses sampling to estimate the values of integrals, evaluate integrand and arbitrary points. Topology. Geometric surfaces, characteristics of the mesh, smoothing meshes, remeshing meshes, and cutting and flattening meshes for UV layouts, elasticity calculation on meshes, and shortness. So, number theory. Number theory algorithms are mathematical tools that deal with integers, primes, modular arithmetic, and other concepts related to discrete values. They have many applications in cryptographics such as encryption, compression, procedural generation, and digital watermark. So procedural generation may be for generating stuff in a map, for example, in a game. So that's it for activity 1.